Ladies and gentlemen, you have been lied to. And not only have you been lied to, chances are you've lied to somebody else about the exact same thing. But it's okay. You probably didn't know any better, just as the person lying to you didn't know any better. I'm talking about the way we explain how lift is created by an aircraft wing. Most of us, if not all of us, have been taught that an aircraft wing makes lift by creating low pressure on the top and higher pressure along the bottom. This lower pressure wants to move to the higher pressure, and therefore the wing moves upwards and creates lift. Except this isn't what a wing does at all. You see, most of us have never heard of a gentleman named Bernoulli. Mr. Bernoulli was an Italian scientist who, after playing with some sewer lines that were broken, found that fluid, and I'll let you guess what kind of fluid he was experimenting with, seemed to move faster in areas where a buildup of, we'll call them solids, had occurred. He found that as the liquid approached the buildup, it seemed to want to be compressed, and that caused the fluid to lower its pressure and increase its velocity. This phenomenon became known as the Bernoulli effect. Venturis are still around. We have one right here, a drawing of one. And you'll find these pretty much in anything that needs a loss of air pressure, or a lowering of air pressure, and an increase in air velocity, such as a carburetor. What you have is fluid going from one end into the restrictive part where pressure decreases, velocity increases, going very quickly to the other side where pressure and velocity return to the values they had before they entered. So here is same as here. Matter of fact, if we look at this and we cover half of it up, we can see that it looks very similar to half of an aircraft wing. And since our atmosphere is fluid and has the properties of a fluid, this meant that Bernoulli's principle also applied to our atmosphere. Except that as we look at a wing, we see that while it's supposed to compress air on the front here as it moves to create the Bernoulli effect, it's almost impossible because the front of the wing is open. That is, we have a surface here, but there's no other surface over here to actually compress the air. If you try to compress the air will simply move out of the way of the wing. And this is how the wing works. As a matter of fact, Albert Einstein believed that the Bernoulli effect on a wing was so incorrect, he actually built a wing that had a rather large hump in it. This should have really compressed the air as it moved, except it didn't, because the Bernoulli effect was incorrect, and thus even Albert Einstein has disproved the Bernoulli effect on the wing. But if it's not the Bernoulli effect, what is it that makes the wing create lift? Well, a wing creates lift using Newton's 3 laws. You remember them, don't you? An object at rest or in motion tends to stay at rest or in motion. The laws of equal and opposite reactions. And the law that states force equals mass times acceleration. Let's see how those play into a wing. First, an object at rest tends to stay at rest until it's affected by an outside stimulus. Okay? The wing actually disturbs the air as it passes through. And this air therefore wants to return to its natural state where it was, and so it flows over the top of the wing. There's actually a small layer of air right over the wing called a boundary layer. It's air that actually doesn't move at all and causes the rest of the air to stick to the wing. Golfers know about this effect because that's the reason golf balls are dimpled. Also, if you've ever washed a car with just a hose, you've gone up to it and noticed it still had dirt on it. That's because the water acted as a boundary layer on the car just as air acted as a boundary layer on the wing. To actually clean all the dirt off the car, you have to break that boundary layer either with soap and or a brush. Next, we have the law of equal and opposite reactions. You'll notice as we look at this airfoil shape here, notice mostly from here back, we have a downward slope. This downward slope is key because as the air comes off, the air doesn't come off the wing going in a straight line, nor does it come off the line and go down. It comes off the wing at a downward angle, also known as a vector because it's a resultant. It's a partial of this and a partial of that. It's a combination of the two. This air coming off of here creates an equal and opposite reaction, which pushes the wing in the opposite direction with the same amount of force that the air is coming off the wing. This is where most of the lift comes from, or at least half of it. Third, force equals mass. Now this sounds all fancy, but all it's really saying is that an object that is moving faster has a tendency to create more force. Thus, if a wing moves faster, a wing can create more lift being a force. Just as when you stick your hand out of the car window. If you stick your hand out of the car window, you'll notice the faster you drive, the more your hand wants to go up. And you can even adjust this with changing the angle of your hand. Thus, the faster a wing goes, the more lift it can make. Now, what happens when a wing goes too slow or flies at too much of an angle? Well, a stall happens, which basically just means the wing ceases to produce lift. Instead of the air sticking to that lovely boundary layer and coming off the back, it doesn't stick to the wing at all and just goes straight, or it comes back around and pushes on the back side of the wing. It's not good if you're trying to fly. If you're trying to do a stall, it's great. So now, we know what creates lift. It's not Bernoulli, it's Newton's 3 laws. So please, stop lying to other people. Not only is it rude, they're more than likely going to tell somebody else what you told them.